So let's talk about one of the most powerful and honestly one of the most consequential scientific discoveries in all of human history, nuclear fission. This is a wild story. It's about a moment of pure genius that unlocked the secrets of the atom, promising this future of boundless energy, but at the same time, it unleashed the potential for just unprecedented destruction.
So that really brings us to the central question, right? How did a process that scientists first imagined as just a simple wobbling drop of water, how did that become the source of both our biggest dreams for clean energy and, well, our absolute worst industrial nightmares? Let's get into it.
You know, to really get a grip on fission, we can't just start in some 20th century lab. Nope. Our story actually begins thousands of years ago, back in ancient Greece. This whole obsession with the atom, the fundamental building block of everything, has been a human quest for millennia. What's just wild when you look at this timeline is the speed, the sheer acceleration of it all. I mean, for centuries, the atom was just an idea, a philosophical concept. Then, suddenly, in the span of a single human lifetime, we go from Rutherford just starting to poke at the nucleus to Enrico Fermi figuring out the key, neutrons. And then a brilliant team, including the amazing Lise Meitner, finally putting all the pieces together and explaining fission. And then boom, by 1942, Fermi's team pulls off the first chain reaction. Just like that, in the blink of an eye, the nuclear age was born.
So you gotta ask yourself, how on earth did they even begin to understand what was happening inside something as tiny as an atom? To explain this totally invisible, world-altering force, two physicists, Niels Bohr and John Wheeler, came up with a surprisingly simple and beautiful analogy.
So what is nuclear fission really? Well, at its heart, it's just the act of splitting the core, the nucleus, of a heavy atom into smaller, lighter ones. But, and this is the whole reason we're talking about it, that one little split unleashes a tremendous amount of energy. And that was the power everyone was chasing. And this is where it gets so elegant. Bohr and Wheeler came up with this idea. They said, hey, what if we stopped thinking about the nucleus as a hard, solid ball, and instead picture it like a drop of liquid? And that one simple comparison just unlocked everything. It suddenly made this impossibly complex physics something you could actually visualize.
Okay, so here's how it plays out, in 3 basic steps. First, bam! An outside neutron slams into a heavy nucleus. Next, the nucleus absorbs that neutron, and just like a water droplet you flick with your finger, it starts to wobble and stretch out. And if that wobble is just violent enough, the nucleus stretches so much it just can't hold itself together anymore. It rips apart, splitting into smaller nuclei, releasing a huge burst of energy, and here's the absolute key, it also releases more neutrons. Those neutrons can then shoot off and split other atoms, starting that famous chain reaction.
All right, so the science is figured out. And for a while there, the world entered this period of just incredible optimism. It was the golden age, a real honeymoon with atomic energy, where it seemed like we had found a magical, perfect solution to all of our energy problems.
I mean, you have to put yourself in their shoes, right? You've got Europe rebuilding after the war and needing massive amounts of power. You've got cities like London literally choking on deadly smog from burning coal. And then the oil shocks of the 70s hit, and suddenly gasoline and heating oil prices are going through the roof. In that world, nuclear power looked like a superhero. It was clean, it was powerful, and it seemed totally limitless. And nothing, I mean nothing, captures that optimistic vibe better than this famous quote, "Too cheap to meter." The dream wasn't just for affordable energy, it was for energy so abundant, so plentiful, that we wouldn't even have to bother measuring how much you used. A promise that, well, looking back now, sounds pretty ironic.
But that honeymoon, it was never going to last. The dream of perfectly safe, clean, and cheap nuclear power was about to collide head-on with a terrifying reality, a series of absolute catastrophes that would completely shatter the public's trust.
3 dates really tell the story. First, 1979, 3 Mile Island in the US. That was the wake-up call, a terrifying warning that, yes, a meltdown could happen here. Then came 1986, Chernobyl, an absolute nightmare, a disaster on a scale nobody thought was possible. And then, as recently as 2011, Fukushima reminded us that even one of the most technologically advanced nations on Earth could be brought to its knees when nature's fury meets nuclear power.
And to be crystal clear about how bad these were, both Chernobyl and Fukushima were rated as level 7 disasters. That is the absolute highest you can go on the international scale. There is no level 8.
As one source put it, these weren't just events or accidents, they were apocalyptic.
And this story of Chernobyl is just dripping with this dark, cruel irony. The whole disaster started during a safety test. Can you believe that? The operators were literally trying to prove the plant was safe, but caught between a deeply flawed reactor design and a reckless procedure, they lost control. And as the source says, all hell broke loose.
Now look, the exact final death toll from something like this is always debated, but the potential scale of the human cost is just staggering. This particular study from 2009 estimated that nearly 1 million deaths could ultimately be attributed to Chernobyl. It's a number that's almost impossible to really wrap your head around, and it just hammers home the terrifying stakes.
So, after all of that, where does that leave us today? Well, the truth is, those great disasters cast a very, very long shadow. And the whole debate around nuclear power is still defined by this legacy of really difficult, persistent, and unresolved challenges.
And the challenges go way beyond just preventing the next big meltdown. Even during normal day-to-day operations, plants release radioactive contaminants. The whole process, from mining and processing the uranium in the first place, all the way to the problem nobody has solved yet, what to do with nuclear waste that stays deadly for thousands of years, it all presents these huge hurdles. It's a stark reminder that the very thing that makes fission work, that unstable, wobbly, liquid drop nucleus, is exactly what makes it so dangerous. It's why for some people, every single reactor still operating today is, in the words of one source, a ticking time bomb.
And so, we kind of come full circle. We unlock the power of the atom with so much promise, with these grand visions of a better world. But now, after seeing its legacy, a legacy of both incredible power and absolutely catastrophic peril, the fundamental question is still sitting there, waiting for an answer. How should we value that promise today?